Hi guys, so today we'll start with a new definition, that is a universal set. So while studying the system of numbers, we are interested in the set of natural numbers and its subsets such as set of all prime numbers, set of all even numbers and so forth. This basic set is called as a universal set. Is it clear? The universal set is usually denoted by capital letter U and all its subsets by the letter of a capital letters of the alphabets A, B, C, etc. The subsets of a universal set is denoted by the capital letters of the alphabets except U, because U is denoted as a universal set. Is it clear? So now, how exactly we can define the universal set is nothing but, for example, I'll just take for the set of all integers, the universal set can be a set of rational numbers. For that matter, the set of real numbers, we can take it as a universal set. So for more another example, if I take it, in a human population studies, the universal set consists of all the peoples in the world. Okay, hope you got it now. The universal set is nothing but, I can define it as a set of all real numbers. As we know that the real numbers, in a real numbers will have integers. Is it clear? Whole numbers, natural numbers, then rational numbers, etc. So hence we can say that the universal set is nothing but it is a set of real numbers. Is it clear? So I'll just go with the one example, that is, so if I take U is 1, 2, 3, 4, 5, 6, 7. Okay, this is what the universal set, where A is 1, 3, 5, where B is 3, 2, 4, and C is 6, 5, 7. So can we say that, is it A is a subset of a U? Yes, of course. 1, 3, 5, which belongs to universal set. Next, B is a subset of U. Yes, B is a 2, 3, 4, which is there. Again, C is a 5, 6, 7. Again, even that is also there. C belongs to universal set. Now, we can say that A, B, C are the subset of this universal set, and this universal set we can call it as, it is a combination of, it is a group of elements of a few more sets. If I consider under a consideration of a 2 or more sets, and those combination of the elements, all the elements of a 2 or more sets will belongs to this universal set. Is it clear? So now I'll go with the one simple example, that is the sets A 1, 3, 5, B is 2, 4, 6, C is 0, 2, 4, 6, 8. Now the question is, which of the following may be considered as universal set for all the three sets A, B, C. Now, is the first one would be the universal set, or second one is the universal, or a third one is the universal, or the fourth one is a universal. You just check with the elements of the following. just tell me the which one will be the universal. So as I said that universal is nothing but it is a combination of subsets of these sets. So all the three sets which contains like elements 1, 3, 5 in a B is a 2, 4, 6, C is a 0, 2, 4, 6, 8. If you write it together these three sets as a one set and that set will call it as a universal set, then which of these four is the universal set? So can we consider this? 0 is there, 1 is there, 2 is there, 3, 4, 5, 6 is there, but 8 is not there in this. Therefore, this is not a universal. Again, null. As we know that the null is nothing but it is an empty set. The set which does not contain any element. Therefore, this is not a universal. Next is in this 0, 1, 2, 3, 4, 5, 6 till 10 is there. Okay. So, if you check with the next option, that is a 1, 2, 3, 4 till 8 is there. But in this we have a 0. Therefore, 0 should be there in this. Then we could have considered this is a universal. So, these three are not a universal. Hence, you can go with the third one, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the universal set for these three sets. Is it clear? So, therefore, answer for this question is the third one is the universal set for a given three sets A, B, C. Okay, clear? Hope this is clear. Now, I'll just go with Venn diagram. This is a new concept again for you guys. So, Venn diagram is, in a Venn diagram, the elements of a set are written in their respective circles. Is nothing but in this, the diagram which is like a rectangle, where the rectangle is represented for the universal set U. Okay, within this whatever the elements, we'll just round off with that, and that circle will call it as a subset of the universal set. Okay, is it clear? We'll just round off the circles. So these circles are denoted for a subsets. So for example, this is what exactly the Venn diagram will be. And here is now illustrate universal set 1, 2, 3 till 10 is the universal set of which A is 2, 4, 6, 8, 10 is a subset. Now we need to draw the Venn diagram for this. We need to illustrate that. So as I said that the rectangle is represented for the universal set, therefore this rectangle is for the universal. In this universal set, the elements which are like 1 to 10. So now I'll just write it, and I'll just write it directly with a circle. So as I said that the circle is denoted for the subset. So now the subset element, you just write it within this circle. Okay, then we'll just write it the remaining elements of the universal set. That is the out of a circle. That is 2, 4, 6, 8, 10. So these elements will be in the circle. Why? Because these elements in a subset. Now the remaining 1 to 10, the remaining elements of the subset we need to write out of the circle and within the rectangle. Is nothing but 1, 2 is already there, 3 is not there, 4 is there, 5 is not there, then again 6 is there, 7 is not there, 8 is there, 9 is not there. Therefore, this is what the illustration for the given example. This is a universal set. It is represented by a rectangle, and for a universal set, the subsets are represented by the circle. Is it clear? So next is the operations of a set. I'll just mention how many operations will be there, then we'll start with the next class, those operations. So operations on the sets, we have first one, union of a sets. The second one, intersection of a sets. Next is the difference of a sets. Difference of a sets. So here is the wordings are different. Okay. So now in an algebraic way, if I explain this one, union is nothing but it is a addition, whereas the difference is nothing but it is a minus, and the intersection is nothing but it is a common elements in both the sets. So this is how exactly we are going to do the problems based on these concepts. So operations is nothing but, operations of algebra is nothing but addition, subtraction, multiplication and a division. So on a sets, we have a 3, that is a union is nothing but addition, intersection is nothing but the common elements, and the difference is nothing but it is a subtraction. Okay, so these 3 will do it in the next class. Hope you guys understood the universal set and the Venn diagram. Okay, thank you guys.